Hi, my name is Mike Oshevsky. I am owner of Reliability Concepts and the designer and inventor of the B.A.T belt alignment tool. What we're going to do is demonstrate very quickly how the belt alignment tool works, and basically the system consists of two lasers which fire onto glow line surfaces, and basically one B.A.T attaches to the drive pulley and the other one attaches to the driven pulley. And what you're going to notice right away is that we have a large target surface on each one of the tools, and the objective is that they fire onto opposing targets while the alignment job is being done. What this does is it provides feedback as to what's happening as you're making the move on your movable pulley or sheave. If we look real quick, what we can do is we have these adjustment knobs here on our demonstrator, okay? And really what we had to do was redesign the demonstrator because we found that the error that's present, even in the other demonstrators, provides a poor alignment solution as well. Okay, so basically just by turning the knobs, we can see over here that we're already on our target, which would be a standard alignment solution. But if we look over here on our driven pulley, we can see that we need to make another adjustment. And if we come over here and look, we notice again that we need to make another adjustment in order to get a precision alignment. Okay, and once the laser really starts to glow bright, it's in the white zone of the target. Then we can come over here and adjust again. And if you take a look, let's bring it over a little more, you can see that immediately we're in the targets, we're on the glow lines, and it becomes apparent just by how many moves I had to do in the way the lasers move that we absolutely need to have two lasers to do an accurate alignment. Okay, and what we're going to do is we're going to pull this unit off of our stationary, and we're going to take some standard targets which are provided with the kit in the event that it becomes impossible to put two B.A.Ts on and you have to execute a standard alignment solution. What we're going to do is put the targets on in a standard 3-target configuration, and what you're going to do is notice real quick that the targets are very strong magnets, number one. But number two, if you look, they are, as we would expect, right on the glow line in the center of the target, which means we have achieved a good alignment. One of the things that you're going to observe is we're going to take and actually move the base of the demonstrator over, and we're going to move it over a substantial amount, and we're going to move the laser off of the 3 targets. And you'll notice as I'm moving it, we're not moving it a little bit, we're moving it on the order of ½ an inch. And as we would very well expect, if you take a look at our 3 targets, we are off the targets. Now, just by moving the inboard adjustment, if we take a look at our laser targets, we can see that we can effectively put the lasers right back on the targets. This is an indication that with the 3-target, multi-target system, we're not achieving a successful alignment. And what we're going to do, just to reinforce what we did, is we're going to push it over again. Now we're in the 3/4 inch range out on just a very small demonstrator. And again, if you look down at this adjustment knob, as I turn it, you can see we go right back on the targets. So the implication is that when you're out in the field doing a belt alignment with the standard single laser shooting on 3 targets, you don't always know for sure that your alignment is correct unless you switch the targets and put them on and then check the job again, costing you valuable time. And at the same time, you really do not know what's happening with the move and how it affects the opposing pulley. So what we're going to do to validate our solution is we're going to put the B.A.T laser back on. And if we look at the laser that is on the pulley, we see we're in the target on the laser that is on the fixed, but if we come over here and look at the movable, we can see we're off a substantial amount. And again, this is over the span of about 16 inches, so the error is even more exaggerated when we are on larger systems. And so if we take and move the lasers again, we can bring the laser back on in this target, again taking back up the amount of offset that we had that went undetected with the 3-target system, and very easily move our system and bring the lasers back into their target lines. One of the things that we've noticed when we've been out in the field doing beta testing and with the systems that we sold and the feedback that we've gotten from our clients is because the two lasers are shooting at each other and have to be in exactly the same plane. If there's an issue such as a scalded shaft or a broken taper lock or some underlying problem with the motor, for example, loose fit in the motor bearings, what happens is the adjustment becomes so extreme to put the two lasers even close to being on each other that it becomes obvious there's another problem inside the machine. So keeping the demonstration real quick, that's the B.A.T cross-firing system, and our next video we're going to update with our simplified offset solution using a very simple set of dividers. Thank you.